Hi, greetings to all. Today we are going to see what is meant by cross validation. Cross validation is a process which is to overcome the problems overfitting and underfitting in data science. Overfitting is nothing but when your predicted and the actual values are having 100% accuracy, then we are calling it as overfitting. Why this is a problem is whenever a new data is given to the model will mark up the data trend and pattern inside the data, and it will not find the trends and pattern in the newly given data. So in that case it will fail to be a generalized model. A good fit is nothing but there can be error, but it will be in less amount, but the accuracy will be more than 90% or 80%. Then we are calling it as good fit. Underfitting is nothing but when the accuracy is less than 40% and the predicted and actual values are not at all matching each other, then we are calling it as underfitted model. So in order to overcome the problems called overfitting and underfitting, we are going for the process called cross validation. So this diagram portrays the difference between overfitting and underfitting. This is nothing but overfitting. When your predicted values are exactly falling on your actual values, then we are calling it as overfitting. Good fit is nothing but your predicted values are falling on your actual values, but there may be reduced error. So in that case we can accept that error and we can call that model as generalized model, and it is a reliable model. But in case of underfitting, your predicted values and actual values are very much deviating from each other. So we are calling it as underfitting. So let us see how to do cross validation in RStudio. For this, I am making use of the package called Caret. Caret package has the functions like create data partition, confusion matrix, train control, etc. So I am making use of the function called train control from Caret package. I am making use of the data set iris. Iris has 150 records in it. So you can have a view on the data set. So it has totally 5 columns: sepal length, sepal width, petal width and species column. I am going to use species column for my classification problem, which is a target in my data set. So with the help of sepal length and petal width of the plants, I am going to identify my species of the flower, whether it is Setosa, Versica or versicolor. So I am calling this data set inside my RStudio. I am going to use a method called k-fold cross validation for my cross validation process. K-fold cross validation is nothing but folding your data set into k-folds. Cross validation is nothing but reserving a subset of data for validation process. In order to do a modeling or else any supervised algorithm, you have to split the data set into training and validation data set. In k-fold cross validation, the dataset will be splitted into k-folds. K is nothing but the number of folds or number of subsets you are going to create out of your dataset. If you are mentioning the k value to be 10, then you will be creating 10 folds of your dataset. I mean the 10 subsets of data will be created. So in this, the 10th subset will be kept for validation, I mean the testing process, and the remaining 9 or 90 records or 9 subsets of data will be taken for training when there are 100 records in your data set. And again some 10 records will be taken for validation process, which is except the previous one, and shuffling of the folds will be happening, and finally the average of the accuracy, kappa statistics and root mean square error, confusion matrix and everything will be finally summarized, and it will produce the result which will produce your generalized model. So all the subsets of data will be shuffled for validation in k-fold cross validation process. So now I am going to give the value of k as 10 for my k4 cross validation process. So I am going to make use of the algorithm called naive Bayes for my classification, and I am going to classify the species column. So when there are 10 folds created in my data set and all the folds are used for validation by shuffling in k4 cross validation, it has produced the results as accuracy to be 0.95% and 0.96 for true and false values, and on an average we will be having 95.5%, and kappa statistics is 0.93 and 0.95%. Accuracy is nothing but the accuracy between your actual and predicted values. Kappa statistics is nothing but the interrelated reliability or agreement of the actual and the predicted values. So both this accuracy and kappa statistics should be greater than 0.5. Thereby we can rely on the model. So it has produced good results. So we have overcome the problems called overfitting and underfitting in our training process. So this is how we have to do k4 cross validation. So thank you for watching this video. Thank you for your time.